Okay, welcome to the k-values and roots with parabolas. So in this kind of question, you're going to be working with parabolas. It's more of an application question. And you might be given a function. For example, maybe it's a simple one like that. Okay. And they say to you, how are we going to, they could say to you, for what value of k will be needed for f of x equals k to have maybe two unequal roots, unequal distinct, they might say unequal distinct roots. Okay, now this kind of question is really very similar to an understanding of when we did quadratic equations or trinomials, where we had to figure out roots. And remember that the roots, and what was the nature of the roots? What is a root, first of all? We have to understand that. Now, a root is something, it's an x-intercept. So basically it is where these parabolas intersect the x-axis, because it is a solution for x. So it is where the parabolas intersect the x-axis. Those are what we call roots. Okay. Now, in this graph, you can see that the one that I've just filled in has two different roots. Okay, which means these would be two unequal, because they're not the same value, distinct real roots. Okay, now, because they have two separate values, and it could be like random values, I don't know, let's just give it like a random value, -5. Maybe it's -5 and -3 or something like that. Okay. Now, the other two I've drawn here are also very important because they're the other type that we get. Now, you can see that this one here is touching the x-axis, but it only touches once. Okay. Which means that we only have got one value for x. Okay. So when you solve that equation, you'll get the same answer, which means you're going to have equal roots. Okay, it's going to be equal. When you solve this equation and you set it to 0, it's going to be equal. You're going to get x equals maybe 2 or x equals 2. You're going to get the same value, which means that this thing is sitting on the x-axis. So whenever you have this situation where you get exactly the same x value, you are going to have equal roots. Okay, and it basically means it's one value for x. Okay, now when you look at the other option, okay, which is right above here, you can see that this parabola, so let's just call this 1, 2, and 3. So the third option, this parabola does not have any x-intercepts. Okay, I mean with the x axis, it has no roots. It's got no roots at all. So it has no intersecting values with the x-axis. So no roots. Okay, when it has no roots or no real values, that means that its x values are non-real. So this is the type where x values are non-real. Non-real. Okay. So that is where it's non-real. Okay, so these are the types of shifts that we'll need to look at for k in order to get something to have two unequal roots, or one root, or no roots. Or yeah. So now let's just connect everything together. So when we are asked, number 1, for unequal So we need unequal real roots. That is number one, or values for x. They might not say roots, they might just say values for x. Okay? They might also ask you for equal roots or equal values for x. Okay, which is option 2. And then option 3 will be non-real. Okay, so obviously the other two will be real values. Okay, real. Okay, now let's do a problem how this will actually be asked in your exam. So it's very similar to the one I put here in the corner. Yeah, but let's actually do one visually so you can see it. Let's start with, okay. I'm going to start with maybe a simple one, and then we can right. Okay, so let's start with a simple one. So let's use that one we had. It was plus 3. Okay, so it was plus 3, so it was here. So it was y equals x squared plus 3. That was the equation that we had, which means that it's going to be all the way up there, and that will be where we are. Okay, right. So once we know where it is, if they ask us now for what value of k do we need to say that f of x equals k for, so what value of k do we need for this thing to be, so for what value of k do we need for this function, for this to have, let's say, 2 unequal real roots. Okay, right. Now, going back to our theory, for this to have 2 unequal real roots, we need it to have two x-intercepts, 2 x solutions. So that means this graph needs to cut the x-axis twice. Now, remember that if we put a number here, so let's think about what that does to the function. So let's just choose a random number for k, just to show you what's happening. So f of x equals x squared plus 3. Okay, if we say let's let k be 2. Okay, so we know that now f of x is equal to that function, so we put that there, and that equals 2. What is going to happen is if we take the 2 across, that is going to become 3 minus 2, which is now plus 1, okay? Which means now this thing has actually it's been shifted down because it's negative 2. Sorry, I'm going to squish that in there. I don't know if you can see, but it's negative 2. We have now shifted this thing down by 2 units. Okay. What happens if we shift this thing down by 2 units? Let's just look at that. So if we shift this thing down by 2 units, everything on the y, remember it's the y with the shift downwards, is going to shift down. So now our turning point will be at 1, okay? If we shift it down, it's going to be the same. It's not going to be any wider, but just excuse my drawing. That's going to be at 1. Now, does it have x-intercepts yet? No, it does not. You can see that it still does not have any x-intercepts. So that means how much do we need to shift this thing down in order for this function to actually cut the x-axis? Okay, so we need something like this, where it's going to be cutting that x-axis. So how many units must we shift this thing down? Right, so let's look at that. If we shift it further down by 3 units, we're going to be touching the x-axis. So if we shift it down by 3, now remember, if it touches the x, it's only going to have one solution. It's going to only have one solution, which is not two unequal roots. Okay, so that means we need to go even further. So if we move it for any value greater than 3, so let's look at that. So let's go with 4. So if we move it by 4 units down, okay, so now instead of being at 0, we're going to go 4 units down. Okay, and this is going to be now at minus 1. Okay, and we are going to cut the axis, and we are definitely going to cut the axis here as well. Okay, which means that we now have two unequal roots. So by how much did we need to do that? Well, can you see that from this point here, from this one that I shifted here, okay, which was, I shifted that one by 3 units. That was the one I shifted by 3 units to get. So let's just erase this one so we can see the rest. Okay, so I shifted that one by 3, so to get it to 0. Now any shift greater than 3 downwards, well, you see that it'll give me, I'll always have 2 distinct unequal values because I'm shifting it down beyond 3 units, which means it's going to go past this x-axis and it's going to be somewhere here. So it doesn't matter, it just has to be a value greater than 3. Okay, so now let's report that in terms of what we need k to be. So if we know that we have to get anything greater than 3, a shift down greater than 3, that means, because remember we looked at this, that means this 2 here needs to be something greater than 3. So it could be 4, 5, 6, 7, anything greater than 3, because that's going to mean it's going to shift it below that x-axis. So we now need to report that. How will we report that? Well, we can just say that k then needs to be greater than 3. Because if k is greater than 3, and I take it to the other side, so let's just show you an example. So that was x squared plus 3 equals, now let's say it's 4. So you take the 4 over. Now you have a shift down by 4 units. You see how it becomes negative. So it's shift down by 4 units. So we need anything greater than 3 will shift this thing down. And that's what we actually need. We need these two solutions, these two roots. Okay, so let's look at another example. I think I'm going to end the video here, and then I'm going to do another example in the next video, I'll do more examples. So basically, that is the gist of it, but we will do more examples in another video.